Okay, so what we're going to use is the property of equality for exponential functions. As long as the b is greater than 0 and is not 1, those are just kind of detailed things. Basically, what you need to know is if b raised to the x is equal to b raised to y, if and only if that x is equal to y. It makes sense. These two values are the same, so if you raise it to something on one side of the equation, it's got to be raised to the same thing on the other side. So for something like this, 3 raised to the x is equal to 3 raised to the fifth. Well, that has to mean that x is equal to 5. So if x is equal to 5, then 3 raised to the x is equal to 3 raised to the fifth. It works both ways because of this if and only if scenario that you used quite heavily in geometry. Is getting the bases to be the same. So what you have, I have a base of 3 here and a base of 9 here. So what I have to do is I have to get the bases to be the same, and I can rewrite 9 as a power of 3. So the way I'm going to write it, I have 3 raised to the x is equal to, and then I'm changing that 9 to 3 squared. So I have 3 squared raised to the 4th. Well, that 3 squared is still 9. It's still 9 raised to the 4th. So I changed that so I could get the bases the same, and then I could make the exponents equal to each other from that property that we just went over. So I have 3 raised to the x is equal to, and using this power of a power property, it's going to become 3 raised to the, and I multiply these, 8th. So what that makes is x is equal to 8. And now it's solved for x. I've figured out what x is. So when I go here to b, I have 2 raised to the 5x is equal to, and I can get this base to become a 2 because 4 can be written as a power of 2, so that becomes 2 squared raised to the 2x minus 1. And so now I have 2 raised to the 5x is equal to 2 raised to the, and I'm multiplying this 2 with that 2x minus 1, and I have to distribute it into that binomial. So it's going to become 4x minus 2. And so now the bases are the same, so now I can set these exponents equal to each other. So I have 5x is equal to 4x minus 2, and subtract 4x, and x is equal to negative 2. So go ahead and pause it here and try to do these next two on your own. I'll leave these as the you try real quick. I'll give the answers in 5 or 6 seconds, we'll say. Stop. Pause it. Okay, so here are your answers. I used the base of 4 for 64. You could have used the base of 2 for both of them. You would have gotten the same answer. You can also do these with inequalities, and you don't need to write this part down. It's the same. Basically, b raised to the x is greater than b raised to the y if and only if x is greater than y. Okay, so if b raised to the x is less than b raised to the y, if and only if x is less than y. All of these have the fractions on the right side. That's not because the inequality is just another thing that can happen. And what I want you to understand is, see how this base is 5? I can't get that to be any other base. So that's going to stay 5 raised to the 3 minus 2x. I need this to become a base of 5. Well, because it's in the denominator, you need to understand that then the exponent then is going to be a negative. So I have negative, and 5 raised to the third is 125. It's going to be 5 raised to the negative 4th. Okay, so then 3 minus 2x has to be greater than negative 4, and you're solving from there. So we'll leave this one. Go ahead and try this one, and then we'll move on. I'll give you the answer now. So to change the base of this 1 over 32, I used 2 raised to the negative because it went to the denominator, and it's going to become 5 because 2 to the 5th is 32. So then x plus 2 is greater than negative 5, and subtract 2, that means x is greater than negative 7. exponential growth formula. All it is really that y equals a times b raised to the x. It's just finding that b that we use the 1 plus r. And so that a is still your initial amount, how much you're starting with whatever scenario it is, whether it's money or population or the amount of users on the website or whatever. That a is still your initial amount. So in this scenario, the first U.S. Census was conducted in 1790. At that time, the population was 3,929,214. Since then, the U.S. population has grown approximately 2.03% annually. Draw a graph showing the population growth of the U.S. since 1790. So basically, I just want you to right now write the equation for it and what each part is going to mean. So because in 1790 the population was this 3,900,000 number, that is going to be my A, and it was growing at a rate of 2.03%. So the R is at 2.03%. Well, in order to use it in the formula, you have to change it to a decimal. And remember, to change it to a decimal, you're going to move the decimal place 2 places to the left. So the R really is going to be 0.0203. So I do this and make the equation 3,929,214 times parentheses 1 plus 0.0203, which is going to be 1.0203 raised to the t. And this is your formula. So understand what the graph would look like. Your y-intercept is going to be at that 3.9 million number. Your x is basically starting at 1790, and you would go so forth. Understand, if you wanted to figure out what was the population in, say, 1950, then you would find the number of years between 1790 and 1950 and use that for t and plug it in, and that's what it would be. Okay. If you wanted to know in what year was the population 14 million, you would type 14 in here for y, and you would have to solve for the t. Okay, so this is a different one. A cup of green tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of caffeine from their system per hour. Draw in graph. We're not going to graph. We're just going to write the equation right now to represent the amount of caffeine remaining after drinking a cup of green tea. So what happens is when you drink it, you have 35 milligrams of water, or of caffeine. So that's your A. So I have A of T is equal to 35. And then in this case, you're eliminating 12.5% of the caffeine. So what you have to understand is that R, because it's eliminating it, you're not growing the caffeine. And this is the important part of this problem, which is why I wanted to go over it, is that it's a decay problem. And when it's a decay problem, you're really, instead of doing A times 1 plus R, the R is actually a negative, so you're really doing 1 minus the R. So in this case, I have 1 minus 0.125 raised to the t, which is the number of hours. So I have 35 times 0.875 raised to the t, and this would be the equation for that scenario. Okay, so here is an example. In 2000, the population of Phoenix was 1,321,000, so forth. By 2007, it was estimated to be this 1.5 million number. Write an exponential function that could be used to model the population of Phoenix. Write x in the terms of the number of years since 2000. So that last part is really important because it's talking about since the year 2000, which in 2000, this was the number of people or the population in Phoenix. So that is the starting amount. That is my A, 1,321,045. Okay. Now I have to find the rate that it declined between 2000 and 2007. I have to basically start an equation with the information that I know. I know the A is that 1,321,000. I don't know what the rate that it changed was or the rate that it grew because it did get bigger. The population did grow between 2000 and 2007. But I know the amount that there was in 2007, and that's going to be my A of T, so that's going to be 1,512,986. And that represents the population after 7 years from 2000. So that's what I'm going to put here is 7. And now I only have one variable and I can solve for that variable. So to solve for that variable, I have to do my order of operations, and I'm working backwards order. Because this R is in this parentheses that's being raised to the 7th, I have to get rid of this A part first. So I'm going to divide by the 1,321,000 number, and that becomes 1.145 and so forth. Leave that number in the calculator, and that's now equal to 1 plus R raised to the 7th. So to solve for R, I have to now take the 7th root of each. After I do that, I get 1.019569 and so forth. I'm going to round to 4 decimal places here. So the rate is a growth rate of 0.0196 and so forth, which really means 1.96%. But when I'm using it in this formula, I'm going to want to use that decimal value. So the formula is A of T is equal to my A times 1 plus that percent, that R raised to the T. So to predict the population of Phoenix in 2013, what would that mean? That would mean I do the same thing. I'm finding A of 13, and I'm plugging that 13 in for T because that's how many years there was since the year 2000. And when I do my order of operations, I do the exponent first, which I get 1.287 and so forth. Keep that in the calculator, then times it with the 1.3 million number, and I end up getting this. Now this is a decimal. I'm talking about population, so I want to round to the nearest whole number. I could get arguments of either way. It's an estimation, so you could round up if it calls for it, but on the other hand, you haven't actually gotten to that next person yet, so you also could keep it rounded down either way. At this point, I would say let's leave it rounded down with that. So I get 2,188,230. All right, that's it for today. Here's a joke that you've been waiting for. How did Minnie Mouse save Mickey Mouse from drowning? She gave him mouse-to-mouse resuscitation.